to our lecture of coupon collector problem. You are an aspiring Momolassi player that of course want to get every single jewel from the collector of 8 different types, including Kim, Thủy, Hỏa, Thổ, Phúc, Lộc, Thọ. The way you collect jewel is by shaking the phone once or many turns to get enough A taps.
Each turn of shaking phone pretends to contain one chance of having a jewel and equally likely to get any single of the n jewel. The question is how many turns you need to shake the phone to get every single jewel. Given n jewel and equal probability to draw every single jewel, so what's the expected value of the number of draws we need to perform to get all n jewel?
Now, let's go over the definition of expected value. Given some probabilistic event, like rolling a dice, the expected value is just what we predict the outcome to be. In the sense of rolling a fair 6-sided dice, every face has the same chance to show up. The probability of each face showing up equals to 1/6. If I roll a dice 200 times, you would expect a value of 3.5. You might say that it is impossible to roll a 3.5 on a 6-sided dice. But the expected value is just the average of every single outcome if we roll the dice for a large number of times. The way we calculate the expected value of an event is the sum of the outcome times the probability of each outcome. Here is the detailed explanation for the expected value 3.5. First, we take xi times pi for each outcome. Then we sum them up and get ex equals to 3.5.
Now, let's introduce the idea of Bernoulli trial. A trial is just some random experiments like flipping a coin or trying a card. A Bernoulli trial is a fancy way of saying on the following condition. First, the trial has to be independent. Secondly, the trial must have only 2 outcomes. Finally, the probability of a success is the same for every single trial. Let's consider flipping a coin. It's definitely independent since the previous throws does not affect the outcome of the current throw. Flipping a coin had 2 outcomes, head and tail, and coin flips always have the same probability. So, flipping a coin is a Bernoulli trial. Collecting full 8 kinds of jewel in Momolassi game is a Bernoulli trial. Because the trial independent, it has 2 outcomes that you only collect new or old jewel, and probability of collecting a Phúc jewel does not affect the probability of collecting Lộc jewel, so it's a kind of Bernoulli trial.
Now, let's consider repeating some Bernoulli trials with success probability of p. The expected value for the number of trials before getting a success is 1/p. Let's consider a wheel spinner with 6 numbers. We define the success as getting a 5 and the failure as getting anything else. We know p is the probability of getting a 5, which is 1/6. And the expected value for the number of spins before getting a 5 is 1/p, which is equal to 6. This makes sense, right? If we spin the wheel 6 times, we expect 1 out of the 6 spins to be a 5.
Let's come back to the game Lassi that you have to collect full collection of 8 jewels to win the big prize.
Let's first consider the case when n equals to 8. Now, let's draw one jewel. The chance of us getting a new jewel is 100% since we don't have any jewels yet. Now, we have 7 jewels that we don't have and 1 jewel that we do have. So, the chance of us drawing a new jewel is 7/8. Now, let's draw a new jewel. Now, we have 2 jewels and we don't have 6 jewels. So, the chance for us drawing a new jewel is 6/8. Let's continue doing that.
In general, for n is equal to 8, if we already have collected I jewel, the chance of us to drawing a new jewel is 8 minus I over 8. Writing this with a variable n, we can say that a chance of us drawing a new jewel is n minus I over n. Now, consider the probability of drawing the first new jewel to be P0, and the second new jewel to be P1, and the third new jewel to be P2. Note that I is indexed from 0 to n minus 1, so Pi is equal to n minus I over n. So, using a formula for the expected value, we know that the expected number of trials before success is 1 over P. So, the expected number of trials before getting the I new jewels is 1 over Pi, which is n over n minus I.
Let En denote the expected number of draws to get all n jewels. We can say that En is equal to En minus 1 plus 1 over Pn minus 1. This makes sense. It's just the same thing we derived earlier. If we use the same formula again, using the fact that En minus 1 is equal to En minus 2 plus 1 over Pn minus 2, we get this. If we do this again, we get En minus 3 plus this sum. And if we keep doing this until 0, we get En is the sum of 1 over P0 to 1 over Pn minus 1, which we can factor n from the sum. So we get n times 1 over 1 plus 1 over 2 plus 1 over 3 plus ... until 1 over n. We call this the n-harmonic number. And there you have it. The answer to our original question is that, on average, we would have to draw n times n-harmonic number of jewels in order to get all n jewels.
We have 8 jewels and we need to draw 8 to 9 times to collect full 9 jewels. This is a graph to illustrate the expected number of draws to collect n jewels, with n goes from 1 to 40.
This is the end of our lecture. Thank you for listening.